So നമുക്ക് ആദ്യം നമ്മുടെ ക്വസ്റ്റ്യൻ തന്നിട്ടുള്ള ഡേറ്റ എന്തൊക്കെയാണെന്ന് നമുക്ക് നോക്കാം. ആദ്യം നമുക്ക് തന്നിരിക്കുന്ന ഡേറ്റ എന്ന് പറയുമ്പോൾ the inner diameter, that is Di is equal to 200 mm. The outer diameter is equal to 800 mm. Then we have given the value of the internal pressure, that is 150 megapascal. Megapascal is same as Newton per mm square as well. Next we are given the value of E, that is Young's model of velocity, that is 72 gigapascal. And we can convert that gigapascal into megapascal, 72 into 10 raised to 3 megapascal, or 1 megapascal is same as 1 Newton per mm square as well. Then we are given the value of mu, that is mu is equal to 0.33. Next we have to find out the question. We are given this data to find out the values of the principal stress. The principal stresses. So there are two principal stresses. One which is the maximum one and which is the minimum one, based on the inner and outer surfaces. So sigma T maximum and sigma T minimum. That will be happening, or that will be, we will be getting the principal stress at the inner surface, and the maximum will be when the radius is taken as the inner radius, and we will be getting the minimum at the outer radius. And next is the maximum shear stress. The maximum shear stress we have to find out, and that is given by the notation tau max. Next we have to find out the increase in internal diameter. The increase in internal diameter. That is given by the notation delta Di. Now we can find these formulas from the data book. First one is the principal stress. So finding out the formula for principal stress, we can go to the data book, that is Mahadevan's data book, and page number 103. Equation is equation number 7.118. In this we will be getting the formula for sigma T as sigma T is equal to Pi into Di square, the whole divided by 4 into R square into 4 R square plus DO square divided by DO square minus Di square. This is for any value of R. So if we are going to substitute R as Ri, if we are going to substitute the value of R as Ri here in this equation, we will be getting sigma T maximum, that is the principal stress at the inner surface. And if we are going to substitute R as R0, we will be getting sigma T minimum, that is the principal stress at the outer surface. So at R equal to Ri, we can rewrite this equation as sigma T maximum is equal to Pi Di square divided by 4 into Ri square, or 4 into Ri square plus DO square divided by DO square minus Di square. Ri is nothing but the inner radius, that is equal to the outer diameter, the diameter divided by 2. Or we can say that the Di is equal to 2Ri. On squaring we can see that Di square is equal to 4Ri square. Substitute that in this equation, we will be getting it as Pi into Di square divided by 4Ri square, we can rewrite as Di square itself. So Di square into Di square plus DO square divided by DO square minus Di square. So these two terms will be cancelled and we will be getting the equation as Pi into Di square plus Du square divided by Du square minus Di square. And we can substitute the values of Pi, Di and Du as Pi is 150 into bracket is the outer diameter is 200 and the inner diameter is 800 divided by 800 square minus 200 square, and on simplification we will be getting the value of sigma T maximum as 170 Newton per mm square. When R is equal to RO, that is, when we are considering the outer radius, when R equal to RO, we will be getting the minimum principal stress. So sigma T minimum we will be getting, and substituting in that formula, the same formula itself we will be substituting for R, we will be substituting for R, we will be substituting it as RO. So we will be getting sigma T minimum as Pi into Di square divided by 4 into RO square. Here it was R earlier, so we are substituting R as R0 here, that is outer radius, into 4R0 square plus DO square divided by DO square minus DI square. And here we can just directly substitute the values which we know already. So Pi is 150 and the inner diameter is 200, so 200 square divided by the outer diameter is 800, so the radius will be 400 into 4 into 400 square plus Du is 800, 800 square divided by 800 square minus 400, 200 square and 200 square. And when we substitute the values, we will be getting the value as the final value is 20 Newton per mm square. So the first part of the question is over. We have determined the value of sigma T maximum and sigma T minimum, that is the minimum and maximum principles that you have calculated. Then we have to find out the value of maximum shear stress. So for finding out the value of max, we know from the standard formula that the maximum shear stress is given by sigma T max minus sigma T min divided by 2. That is the difference of both the principal stresses divided by 2. Next, we can find out the increase in internal diameter, and that is also given in the data book. So the increase in internal diameter is given by the formula. The increase in internal diameter. Internal diameter is delta Di that we have used here. So increase in internal diameter is given by the formula delta Di is equal to Pi into Di divided by E into Do square plus Di square the whole divided by Do square minus Di square plus mu, is the Poisson's ratio. This is given in equation 7.14a, page number 104 in the data book. So we know the values of Pi, Di, E, Do and mu. So just we need to substitute here. Pi is 150 and Di is 200. And we know the value of E as 72 gigapascal, and when we convert into Newton per mm square, it is 10 raised to 3. We multiply that by 10 raised to 3. Then the outer diameter is 800 and the inner diameter is 200. Just substitute that. and the value of Poisson's ratio of 0.33. And in substitution, we will be getting the value of delta Dm as 0.6097. So we can approximately say it to be 0.61 mm. We will be getting the value of dA approximately as 0.61 mm. So we will be getting the value of dA, delta dA, and approximately we will be getting it to be 0.61 mm.